Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The strength of an ammonium acid, RNH3+, R2NH2+, R3NH+, depends on the basicity of the corresponding amine. A weaker base gives a stronger conjugate acid. Basicity of amines is reduced by 1. Resonance delocalization of the lone pair into an aromatic or unsaturated system. 2. Inductive field effects. 3. Hybridization, sp to sp3. Analysis of each option. A. NH4+, conjugate base is NH3, ammonia. Ammonia is a simple sp3 amine with no alkyl groups. pKa of NH4 plus 9.25. B. Protonated 1, 2, 3, 4 tetrahydroisoquinoline. This is a secondary amine where nitrogen is in a fully saturated ring but adjacent to a benzylic CH2. The nitrogen is sp3. The conjugate base is a secondary amine with benzylic substituents. pKa of conjugate acid 9.510. This is a moderately strong base. C. Protonated 1, 2 dehydroisoquinoline, or the structure shown, N is directly attached to the aromatic benzene ring with a double bond in the ring system, making the nitrogen essentially an aniline type or vinylogous amine. Looking at the structure, the N in option C is at the 2 position of the dehydroisoquinoline where the C1 is equal to N bond or the N is directly bonded to the aromatic ring carbon. This means the nitrogen lone pair is delocalized into the aromatic ring, analogous to aniline, drastically reducing basicity. The conjugate base amine is very weakly basic, like an aniline derivative, pKa of conjugate acid 5 or lower. This makes the conjugate acid, C, the strongest acid among the options. D. Protonated piperidine. Piperidine is a secondary aliphatic amine, one of the most basic amines. pKa of piperidinium 11.1. This is the weakest acid in the series. Ranking of acid strength, highest to lowest, C, A, B, D. Option C is the strongest acid because the nitrogen in 1, 2 dehydroisoquinoline is directly conjugated with the aromatic ring, analogous to an aniline type nitrogen, sp2 or near sp2 character, making it the least basic amine and thus giving the most acidic conjugate acid. Why others fail? A. NH4+ is less acidic than C, because NH3 is more basic than the aniline type amine in C. B. The tetrahydroisoquinolinium ion has a more basic nitrogen, sp3, secondary, benzylic, than C. D. Piperidinium is the least acidic because piperidine is a very strong base. Therefore, the correct answer is C. Therefore, the correct answer is option C.